NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
The James Webb Telescope has uncovered evidence of a massive force that existed before the Big Bang, and it could destroy everything we know. It seems the universe wasn't born from nothing but from a violent collision with another cosmos. These new discoveries challenge everything scientists believed about the start of time itself. Could this force still exist, shaping and even threatening our universe? Tune in as we reveal the terrifying truth that says a new collision is around the corner. What happened before everything began? For decades, scientists have debated what came before the Big Bang. To some, like the late Stephen Hawking, the question is meaningless. Hawking famously compared asking what happened before the Big Bang to asking what lies north of the North Pole. In his view, time and space began with the Big Bang. There was no before, but not everyone agrees. Physicists like Michio Kaku and others argue that there could be a deeper explanation, one that involves a multiverse of countless universes interacting with each other. String theory, for example, proposes that the universe isn't made up of simple particles, but of tiny vibrating strings. And in this vast multiverse, universes might collide, merge, or even split apart, creating events like the Big Bang. Before we delve into this, it's clear that the Big Bang might be hiding a reality far more unsettling than we ever imagined. And this revelation is just the beginning. The evidence for this cosmic web of universes comes from the very beginning of time itself. Back in the 1920s, astronomers discovered that galaxies are moving away from each other. This led to the realization that the universe is expanding, and by rewinding the clock, scientists calculated that everything began about 13.8 billion years ago. The Big Bang theory describes a singularity, a point of infinite density where all matter, space, and time originated. But there's more to the story. Right after the Big Bang, the universe underwent a period of rapid expansion known as cosmic inflation. In a fraction of a second, the universe grew exponentially, a process so fast that it's hard to comprehend. Yet scientists are still confused about how this inflation happened and what caused it to stop. One explanation involves the idea of an inflation field, a strange force that drove the rapid expansion. This field might have transitioned from a false vacuum, a high-energy state, to a true vacuum, a lower-energy state, releasing energy that created the universe as we know it. But here's where things get tricky. Quantum fluctuations, or tiny random changes in the energy field, could mean that inflation never stopped completely. Instead, it could have continued in other regions, forming new bubble universes along the way. If this is true, then our universe is just one bubble in an infinite multiverse, each with its own unique properties and laws of physics. The James Webb Telescope has recently added fuel to this debate. By examining distant stars and galaxies, JWST has provided new insights into the rate at which the universe is expanding. Scientists have long used the Hubble constant to measure this expansion, but there's a catch. Different methods of calculation give different results. One method, using the cosmic microwave background, the afterglow of the Big Bang, gives a value of 41 miles per second per megaparsec. Another method, based on supernovae and variable stars, gives 45 miles per second per megaparsec. This discrepancy has baffled scientists for years. JWST's precise instruments have confirmed that this mismatch is real, suggesting something unusual is happening. Some researchers believe the faster-than-expected expansion might be caused by unknown forces, such as exotic particles or dark energy. But a groundbreaking study suggests another possibility. Our universe might be merging with others. According to this theory, the energy released during these collisions could drive the accelerated expansion we observe today. This idea isn't just speculation. The study's calculations match real-world data better than traditional models. If this theory is correct, it means that our universe's history is deeply intertwined with other universes. The initial inflationary period might have been triggered by our universe being swallowed by a larger mother universe. Over time, our universe could have collided with and absorbed smaller baby universes, creating the conditions we see today. This perspective reshapes our understanding of the Big Bang. Instead of a singular event marking the beginning of everything, it becomes a local event, the point where inflation stopped in our bubble. Meanwhile, inflation could still be happening elsewhere, creating new universes even now. If our universe is only one of many, the forces shaping it might be even stranger than we imagine. The endless expansion of space explained. But what does this mean for the ultimate origin of everything? Even if this theory explains the Big Bang, it doesn't solve the deeper question of where the first universe came from. In this sense, the Mother Universe theory pushes the question back a step rather than solving it. Still, it offers a fascinating framework for understanding the cosmos and suggests that the universe is far more dynamic and interconnected than we ever imagined. The JWST's findings have also reignited debates about the nature of dark matter and dark energy. These strange substances make up most of the universe but remain poorly understood. If our universe is merging with others, could dark matter and dark energy be the remnants of these collisions? Some scientists think so. The merging of universes might leave behind traces that we perceive as dark energy, driving the accelerated expansion of space. This perspective could revolutionize our understanding of these elusive forces and open up new avenues of research. The implications of this theory are staggering. If the multiverse exists, it means that anything that can happen does happen somewhere. There could be universes with different laws of physics, where time flows backward, or where stars never form. It also raises philosophical questions about our place in the cosmos. Are we just one of countless civilizations scattered across an infinite multiverse? And if so, what does that mean for our understanding of existence? The JWST's ability to peer deeper into the universe than ever before offers a unique opportunity to test these ideas. By studying the oldest light in the universe, known as the cosmic microwave background, scientists hope to find patterns that could indicate interactions with other universes. For example, a collision between two universes might leave behind a circular pattern in the cosmic microwave background, like a fingerprint of the event. While such evidence remains elusive, the possibility is tantalizing. The scope of these discoveries extends beyond pure science. It challenges the boundaries of what we believe to be possible. When we think about how the cosmos operates, these ideas force us to abandon traditional thinking and imagine an interconnected, endless web of realities. From a practical perspective, understanding these phenomena could even lead to technological breakthroughs. By unlocking the mechanisms behind cosmic inflation or the merging of universes, we might one day harness forces or energies previously thought impossible. Such advancements could redefine humanity's relationship with the universe. Another key question lies in the nature of time and causality. If our universe arose from the collision or absorption of other universes, does that mean time as we know it is merely a localized concept? Some physicists argue that time might flow differently or even cease to exist in other bubbles of the multiverse. If these alternate realities exist with differing time structures, it could profoundly alter our understanding of causation and existence. Exploring these possibilities isn't just about understanding where we came from, but also about redefining our approach to reality itself. The cosmic microwave background remains one of the richest sources of information for unraveling these questions. Tiny fluctuations in this ancient light contain clues about the early universe's conditions and might reveal interactions with other universes. Recent studies have searched for anomalies, regions where the cosmic background doesn't match predictions. These anomalies could be the result of universe collisions or remnants of structures from before the Big Bang. Detecting such patterns would provide groundbreaking confirmation of the multiverse theory. Even beyond the physical implications, these ideas resonate on a deeply human level. They inspire questions about purpose, identity, and connection. If our universe is part of an infinite system, what role do we play in this grand scheme? Are we an isolated phenomenon, or does life flourish in countless other forms across the multiverse? The answers may lie far in the future, but the search itself embodies humanity's drive to explore and understand. As we push the boundaries of our knowledge, the James Webb Space Telescope's mission will continue to shape the future of cosmology. Its ability to observe the faintest and most distant objects in the universe allows scientists to reconstruct events from billions of years ago. By piecing together this cosmic problem, we may inch closer to understanding whether the Big Bang was a singular event or part of an eternal cycle of creation and destruction. The road ahead is filled with challenges. But each discovery brings us closer to comprehending the true nature of existence. As we learn more about the universe, we find hidden forces and unseen matter that hold galaxies together and push them apart. The search for the universe's missing pieces. The universe is mind-blowingly vast and full of things that don't make much sense to us yet. Imagine a playground so enormous, it stretches beyond what we can see or measure. For all the progress we've made in understanding stars, galaxies, and planets, some of the biggest questions about the universe remain unanswered. What are the invisible things shaping galaxies? What's speeding up the universe's expansion? Let's dig into some of the most confusing stuff out there, from invisible forces to the strange physics that could rewrite what we know. Most of the universe's mass isn't something we can see or touch. It's what scientists call dark matter. This stuff doesn't emit light, absorb it, or interact with regular matter in any obvious way. But it's there, holding galaxies together with its invisible gravitational grip. The problem is, nobody knows what it actually is. Scientists have guessed it might be tiny particles called WIMPs, or something called axions, but no one's found solid proof yet. Without it, galaxies as we know them wouldn't exist, which makes finding it a pretty big deal. If dark matter is the glue holding galaxies together, dark energy is the force tearing them apart. This strange anti-gravity makes up almost 70% of the universe and is driving everything to spread out faster and faster. It's like the universe is running away from itself, and we don't know why. Some think it could be a constant force built into space itself, while others suggest it's something entirely new. Whatever it is, understanding dark energy could change everything we know about the cosmos. Black holes are the universe's wildcards. These regions are so dense that their gravity traps everything nearby, even light. While we know they exist, they come with big questions. What's at the center of a black hole? Scientists call it a singularity, where density becomes infinite. But that idea breaks the laws of physics. Then there's the information paradox. Does anything that falls in a black hole get erased from the universe, or is it stored in some weird way? Solving these riddles could rewrite the rules of reality. Galaxies come in all shapes and sizes, from spiral beauties like our Milky Way to chaotic blobs of stars. But how did they get this way? Dark matter, star formation, and gas dynamics all play a role, but the exact recipe is still a question. And then there are galaxy collisions, like cosmic car crashes that reshape everything. These interactions can spark new starbursts or swallow entire galaxies. Figuring this out means uncovering how the universe grew into what it is today. Magnetic fields are everywhere in the cosmos, from stars to massive galaxies. But how did they form? Some theories say tiny magnetic fields popped up right after the Big Bang, and over time they grew. Others think star explosions or spinning plasma amplified them. What's clear is that these fields play a massive role in how galaxies evolve and stars are born. Cracking this code is like finding the missing piece to a giant cosmic problem. When massive stars explode, they leave behind neutron stars, tiny, incredibly dense objects. Imagine cramming a star's worth of material into a ball only a few miles wide. Inside these stars, matter is so packed together that we can't even recreate those conditions in a lab. Scientists study pulsars, which are neutron stars that spin and send out beams of light, to understand their weird physics. But the more we learn, the more questions we have about what's really happening inside. Gamma-ray bursts are flashes of energy so powerful they outshine entire galaxies for a few seconds. They're thought to come from dying stars or neutron star collisions, but we don't fully know. What makes them so energetic? How far back in the universe's history do they go? Each burst is like a cosmic fingerprint, holding clues to the life and death of stars billions of years ago. The cosmic microwave background radiation is like an ancient photograph of the universe, taken just a few 100,000 years after the Big Bang. It shows us what the cosmos looked like when it was still young and hot. But some parts of this photo don't match what we expect, like strange temperature patterns. These quirks might hint at physics we haven't discovered yet. Even as we figure out how the universe works, big questions about time, life, and its future take us to surprising new ideas. The origins of everything we see today. When the universe was born, it should have created equal amounts of matter and antimatter. The problem is, matter and antimatter annihilate each other when they meet. So why does matter dominate the universe? Something must have tipped the balance early on, but we're still trying to figure out what. What if our universe is just one of many? Some scientists think there could be countless other universes with different rules of physics. The idea comes from theories in quantum mechanics and cosmology, but it's impossible to test, for now. If true, the multiverse could explain why our universe seems so perfectly fine-tuned for life. We live our lives by the ticking of the clock, but time might not be as simple as it seems. Some theories say time isn't a fundamental part of the universe. It's something that emerges from deeper physics. If that's true, what does it mean for how we experience reality? It's one of the biggest open questions in science and philosophy. With billions of planets out there, it seems almost certain that life exists elsewhere. But we haven't found it yet. This contradiction is called the Fermi paradox. Where is everyone? Some think advanced civilizations might avoid contact, while others believe life might be rarer than we think. Either way, searching for life beyond Earth is one of humanity's most exciting quests. Right now, physics has two major theories: general relativity, which explains gravity, and quantum mechanics, which explains the behavior of tiny particles. The problem is they don't work together in extreme conditions like black holes. A theory of everything that unifies these ideas is one of science's ultimate goals. It could unlock answers to some of the biggest questions about the universe. Cosmic rays are tiny particles that zip through space at nearly the speed of light. Where do they come from? How do they get so much energy? These particles smash into Earth's atmosphere, creating showers of secondary particles that scientists study to learn more. They're like nature's particle accelerators, revealing physics at the universe's extremes. Interstellar gas and dust might not sound exciting, but they're the raw materials for stars and planets. Understanding how these components interact with gravity, radiation, and magnetic fields is key to figuring out how galaxies evolve. The challenge is these interactions are incredibly complex and often chaotic. Neutrinos are tiny, ghost-like particles that rarely interact with matter. They're produced in nuclear reactions, like those in the sun or exploding stars. By studying neutrinos, we can learn about processes happening deep inside stars and other extreme environments. Right after the Big Bang, the universe underwent a rapid expansion called inflation. This explains why the cosmos looks so uniform on large scales. But what caused inflation and how did it stop? Scientists are still piecing together the details. Galaxies don't just float around randomly. They form clusters, superclusters, and vast filaments connected by dark matter. These structures are like the scaffolding of the universe, shaped by gravity and the interplay of matter. Understanding how they formed helps us trace the history of the cosmos. Could there be types of matter we've never encountered? Some theories predict states like quark-gluon plasma or strange matter, which could exist in extreme environments like neutron stars. Studying these possibilities could expand our understanding of the universe's building blocks. The universe could keep growing forever, shrink back down, or stay about the same size. What happens depends on dark energy and how much stuff is out there in total. When we figure this out, we'll know the final destiny of everything. There are so many questions out there about the universe that challenge our knowledge. Invisible forces that shape entire galaxies and the strange idea of other universes are just the beginning. Each question leads us to more discoveries. Digging into these ideas helps us figure out not just the stars in space, but also where we fit into the big picture. Trying to understand the universe is like piecing together a giant cosmic problem without knowing what the final picture looks like. We look into the vastness of space and wonder about the forces at play, from gravity pulling galaxies together to dark energy pushing them apart. These forces and the cosmic dance they create might hold the clues to understanding not only the universe's future, but also its past. As we explore more, we learn more. Not just about the stars and planets, but also about ourselves and our place in this vast, expanding space. Could the universe's origin be a cosmic collision? Or is there an even darker truth scientists are hiding? Tell us what you think, and don't forget to like and subscribe for more.